All right, this lesson's going to be on probability. Your homework is going to be a worksheet that you can complete after you take the class notes. So let's look at this bell ringer first. Write your answers as a reduced fraction. Determine the probability of each event if you randomly select a cube from a bag containing 6 red cubes, 4 yellow, 3 blue, and 1 green. So the first thing you should do is find the total number of cubes in the bag. So if you add 6, 4, 3, and 1, you should find that the total is 14. Number 1 wants the probability that you select a red cube. So there are 6 red out of 14 total. But you can't leave your fraction like that. You have to reduce. So divide each one by 2 and you get 3/7. Number 2 is the probability of choosing a blue one. So there are 3 blue out of 14, and that fraction does not reduce, so you can keep it as 3/14. What's the probability in number 3 that you pick a cube that is not red? So if 3/7 is all the red ones, then that means the other part of a fraction that would make that a whole is not red. So that's 4 out of 7. If you don't see that connection, 6 out of 14 are red, so that means 8 out of 14 are not red. Or you can add the yellow, blue, and the green together to get the 8 and reduce. And number 4, what is the probability that you select a white one? Well, since there's no white cubes in the bag, the chance of that happening is 0. Number 5, Jim rolls a die with 6 sides. What is the probability of rolling a 5? Well, if you know, a die has 1 through 6 on it, and there's only 1 5 out of the 6 sides, so that is 1/6. All right, so here is the notes. So please make sure you have a note packet and take these notes as I show you here on the screen. So we're going to be talking about theoretical and experimental probability. Theoretical probability is the ratio of the number of favorable outcomes to the total number of outcomes. For example, the theoretical probability that a coin lands heads up is a half, or 50%. And in theory, tails should come up 50% of the time. But if you do an experiment where you have this frequency table, say you did this experiment, you tossed a coin 10 times and you record the outcomes. Heads came up 3 times, tails came up 7. So in this case, the experimental probability is 3 out of 10 for the heads landing up. So sometimes you want to know in theory what should happen versus what actually happened if you did an experiment. The experimental probability is the ratio of number of times an outcome actually occurred to the number of total events or trials. So if I wanted the experimental probability of the tails, it would be 7 out of 10. But theoretically, it would happen 50% of the time. So theoretical probability is what is expected to happen in the long run, and experimental probability is what actually happens in an experiment. So make sure you know the difference between those two. All right, so let's do some examples. A die is rolled 50 times, so that is our total, and the results are recorded. Find the experimental probability of rolling at least a 5. So rolling at least a 5 means you can roll a 5 or a 6. So if the total is 50, but a 5 or a 6 came up 13 times total, then your correct answer should be C, 13/50. You should always ask yourself, does your fraction reduce? In this case, it doesn't, so you can keep it as 13/50. The next example, students were asked how they travel to school each morning. Find the experimental probability of randomly selecting a student who does not ride in a car or a bus. So the first thing you should do is find the total. So if you add up all of these, you should get 47. If I want the ones that don't ride in a car, I can cancel those out, and don't ride the bus. So we're only talking 9 students out of 47. So that answer is F, 9 47ths. Next example, a movie theater employee surveyed a sample of customers as they exited the theater. Find the experimental probability of randomly selecting a customer who is older than 12 but younger than 46. So again, added those up to find the total. There should be 254. And I want someone that's older than 12, so I can cross off these two, but younger than 46. So I'm not including those two either. So this is my range. So if you add these up and put it over your total, you should see that that's 157 over 254. And that fraction does not reduce. All right, this last example says Shannon's digital media player has a large collection of songs. She randomly toggles through the songs and then records the genre. The graph shows her results. Find the experimental probability of selecting a country song. So we know that there's 24 country out of the total. So we need to add up country, pop, rap, and rock. And we should find that the total is 100. So 24 out of 100, and that reduces to 12/50ths. But actually that reduces one more time to 6/25ths. All right, and part B. Find the experimental probability of selecting a song that is not rock. So that means you want country, pop, and rap, because those three are not rock. So that happens 71 times out of 100. So you can add 24, 33, and 14 to get 71 out of the total 100. All right, I know this is in your notes, but we're actually going to skip this part since I'm not there today. So now you're going to do a pop quiz. So you're allowed to use your notes, but raise your hand and the sub will give you this sheet. And the first two you need to write as a fraction, and these last two need written as a percent. And then after you complete the wrap up, turn it back into the sub, and he will give you your homework that you can work on for the rest of the class period.